Okay, we're in business. All right, so this is college algebra, right? Everyone's in the right place? All right, what I want to do is I want to take you through the syllabus, and then we'll go ahead and we'll start. You know, we got a lot to do. We've got 2 hours, 40 minutes in here. It's a long time. We will take a little break, you know, somewhere in there, about an hour, 15 minutes in. We'll take a little 10-minute break, come back. All right. So this is the Northwest Vista web page, and hopefully you've done this already. Logged into ACES, right? If you haven't, this is the way you do it. Okay, you go here, and then you log in right here. And if you don't know your ACES username or any of that information, click here and you can get that. So my keyboard is not working. I have like a little keyboard I usually have up here, so just bear with me for a second. This ought to be interesting here. Let me do it this way. I don't want you all to see my password. Okay. So once you log in, you should have a little tab here that says My Courses. Click on that, and then you can select what term. I usually just put whatever semester you're in here. We're in summer 2014, and then the math class that you're in, which is college algebra. These are the other classes I'm teaching this summer. So, all right, this is the main page for this class. I expect that every student can get to this page. All communication will be done through this. All right. So we don't use personal emails, your Yahoo account, or anything like that. Everything is done through this system. It usually does take a few minutes to load. Not minutes, seconds. We'll see what happens. There it is. Okay, so this is the main page. You have an inbox up here, and in that inbox, that's where you can check your email. And I'll let you kind of mess with that. There's another thing here, settings. This is kind of important. I'll just let you see it real quick. What you can do, I'm assuming some of you are in for the summer and you normally are off at other schools and you're just, this first time you've ever used the system, so I just want to show it to you. There's something over here after you click settings called notifications. And if you do that, if you click that, then what you can do is you can choose things that happen, like if I post a file, okay, if I post a file on our page, you can choose to add email addresses like a Yahoo account or Hotmail, or you can even add a cell phone. And so that if something happens here, you'll get, you know, a text message that says, hey, you know, your teacher dropped a file or something like that. That way you don't have to always come here. You could go to your, you know what I'm saying or not? You can have it all notify you somewhere else, but you have to set that up. And you can also tell it how often. So like if I want any file updates to go to my Yahoo account, then I can have it send it to me right away. So as soon as the file's posted, I'll get an email, or I can have it send it to me at the end of the day, like a summary of all the activity, or I can do it monthly or weekly, which really doesn't serve much of purpose, or don't send it at all. So just FYI, that's something you can do. The only drawback to this is that it's universal, meaning if you have 5 classes, then whatever settings you have here apply to all 5 classes. It's not course specific. So, yeah. All right, let's get back to the class. All right, so we have the syllabus, and then we have the schedule, which I just handed you the schedule. But if you lose it, that's where you can get it. Just click there. The schedule is tentative, meaning that it's subject to change. It'll just depend on how far we get each day. And the homework assignments, those homework assignments that are listed on the schedule are also tentative. Normally what I'll do is at the end of class, I will look at the homework assignment. I'll say, yep, we covered all that. Go ahead and do that. Or I'll say, just do these. Okay. So make sure that you, if you're not here for some reason, that you go back and watch the video. That way you don't do the whole homework assignment and then realize that I said only do half of it. Make sense? Okay. The class videos. Once I'm done here, I upload the video to YouTube. It takes about a minute to upload the whole video. Then it takes YouTube about 10 minutes to process it and make it available. So usually within, I'll say within 24 hours just to give myself some time, but I would say usually within an hour of class being over, the video of the course, the class will be out here, okay? Now what you can do, click on videos and it'll take you to a playlist that I have in YouTube, and right now there's no videos here, but that's where they'll start to appear, and they'll appear, I believe I have it set to go in chronological order, newest on top. So as we go, the first video will be the most recent class. To give you an idea of what a video will look like, let me just bring up, let's see, okay, this was my Cal 3 class yesterday. This was their first day. Just so you can see what the video will look like. And I'm going to mute myself here. Don't worry about that. I picked the wrong class to show you here. Here we go. This is me. I'm using OneNote, and I'm writing on this, and it's projecting up there, and that's what you will be able to see and hear whenever you go home. Does that make sense? Okay. All right. So that's the link to the videos, all right? And then the notes, as I write everything down, like here are my notes from my class yesterday, what happens is these are different pages, and I save it as a PDF file. I post it on Canvas, and then you go there, and you can actually click on class notes here, and they should appear over here. Right now, there's nothing in class notes because I haven't done a class yet, obviously. And then there's also the administrative stuff. There's your schedule if you want to get that. That's another way to get to the schedule. But does everyone make sense? The class notes will be there. Okay, so everything I write, you can theoretically print off. All right, back to the home page. You can't really see this over here. I'm having some issues with that projector, so let me just move this over a little bit. This is your home page. The files, that'll take you to the same, that does the same thing that this one does. Grades, this is where you'll be able to check your grades, okay? So as the course goes on, assignments are turned in, quizzes or exams, I'll post your grades there and you'll kind of be able to keep up with things, all right? People, I think that's just a way that you can find classmates if you want and email them, or, I mean, of course, keep it related to the class. Don't get crazy on anyone. Let's see. We need space. How are we going to do this? Is there, can we roll that chair over to the end of this table right here? Right there. Yeah, just for now. And sir, you'll just stay there and we'll kind of adjust things. All right. Can you see okay over there? You're good? Okay. All right. Anything else here? No. Okay, let's talk about the syllabus. Now, everyone hopefully can read, right? So I'm not going to do this word for word, just hit the major points. We are here for an 8-week term. We do meet from 2 to 4:40. I accidentally put on there, I just fixed it this morning. I actually had put 2 to 4, but our class is from 2 to 4:40. I wish it was 2 to 4, but it's 2 to 4:40. And we're in the right room. This is the math department. If you need to go to the math department for something, then they're right here. Just go down one floor. It's at the end of the hallway over here, room 213. That's the phone number. I didn't introduce myself. Robert DiGiovanni is my name. This is misspelled. It's a capital G, but I don't really care. Call me anything respectable, you know, Sir, Robert, Mr. D, whatever you know, just not Bobby, not Bob. Those are the two things I don't go by. This is my email address that you don't need because you can do everything through the Canvas, but just in case, there's a backup email. My office is in the first floor of this building. If you need to come to my office, which I encourage you to do for help, if you need help with anything, you actually have to go out of this building to a stairwell and then go down all the way to the first floor and then come back in the building. There's no staircase that goes from here to the first floor in the building. All right? They say that they meant to do it. I think it was a mistake, personally. All right, so you have to go out, down, back in. This is my actual cell phone number. I have 2 internet courses that I teach, so I have to make myself available to my internet students, so I make myself available to all my students. All I ask is that if you text me, it's fine, I receive text, that's okay. Just make sure if you text me, let me know who you are and what class you're in. If you just say, hey, I missed class today, what did I miss? Then I don't know who you are, I don't know what class you're in. And I'm also a little upset because if you ever miss a class and you want to know what you missed, what should you do? Go watch the video, right? I mean, that's why it's out there. But every semester I have people ask, what do I miss? Well, did you watch the video? No, not yet. Well, go do that and then ask me any questions. All right, my office hours. So I will be available in my office for you to come in for help. Okay, so free tutoring from me, which means that I'm the one who knows best what I'm going to ask of you, right? And the way I show you to do things. So a tutor can help you, but if you can make these times, that's probably your best choice in getting help. So I'm there actually before this class for an hour and a half, just sitting down in my office, just waiting for someone to come in and ask for help. All right? So please come by. And then on Monday, Wednesday, I'm there from 11:30 to 1. The campus is closed on Fridays, so nobody's here on Friday. All right, the book that you need is this one. Has, what is that, Nemo on the front? Nemo and a couple of his buddies. All the information is there. Has anyone tried to get it yet? How much is it? Bookstore or no? You get it at bookstore? You get Amazon? How much do you pay? Oh, wow. Okay. Well, you need it soon, though, okay? So let's say you've got to have it by next week, all right? So if you're going to do Amazon for 30 bucks, expedite that shipping. Get it to yourself quick. Anything else? You also need a scientific calculator. So scientific calculator is pretty much any calculator that has a bunch of keys that you don't know what they do, right? That's scientific. If it has just plus, minus, divide, multiply, then that's probably too basic. If you have any questions, let me know. Bring your calculator to me, and I'll tell you if it's okay. You may not use your phone. Got it? I mean, if we're sitting here doing a class activity or something, just sitting here doing a regular lecture, you pull out your phone, do something, that's fine. But if it's a quiz or a test, no phones. All right? So I don't want anyone to get, all freaked out when they pull their phone out for the test and I say you can't use it. Don't freak out. All right, here's what we're doing. Description of the course, blah, blah, blah. You can read through that. Objectives, blah, blah, blah. Outcomes, blah, blah, blah. And then the grade. So standard grading scale. This is a college level course. We teach a lot of developmental math here. This is college level, which means that there's A, B, C, D, F. And this is the way it's broken up. I do round up. Okay, so an 89.5 would be an A. Anything below a 70 is usually not enough for you to get credit for whatever degree you're going for. Most colleges won't accept D's and F's. So everyone here has to at least be shooting for a 70, right? I only say that because this is Math 1314, which is what we call a terminal math class. A lot of people that are in here do not have to take more math. Would I be correct if I look around? Is everyone's like, this is the end of the road math-wise, and I'm happy about that, right? Okay. Anybody who's planning to take pre-cal or more math, you're in the wrong place. So is there anyone who needs pre-cal? You're an engineering major? Yes? Okay. Really? You should, you should, well, but you need pre-cal? Then you have to take 14-14, not 13-14. So what about that? Okay, so okay, okay. So, all right, so you're getting the foundation built up again. Okay, all right, that's fine, that's fine. I just don't want people to be surprised, like, hey, take this class and then go to register for pre-cal next semester, and they're like, no, we won't take that credit. All right? All right, the breakdown of the grades. So how's your grade going to be determined here? I'm going to give you quizzes, and I'm going to give you homework assignments. And that's going to be 15% of your grade. Now, most of it's going to be quizzes, most of it. The only thing that I'll do usually with homework is I'll come around and I'll ask to look at it. And I'm not going to look at every problem and, oh, you skipped one or anything like that. I just want to see you made an honest effort at what was assigned. Because in a summer course, I don't have time to grade 28 homework assignments and get them back to you in a reasonable amount of time, right? So the homework is on you. I give you mostly odd-numbered problems, which means the answers are in the back of the book. You get help from the tutoring lab. You work that out. You bring that in next class. I may use that as a grade. Otherwise, I'll just give you a quiz. That quiz may be in the form of, hey, everyone take everything off your desk, take out a sheet of paper, here's a problem. Or it may be, here's 2 or 3 problems, work in groups. It just depends. It may be at the beginning of class, maybe midway, it may be at the end. We may have a quiz at the beginning and the end. It just depends. If you miss a quiz because you're absent, you miss the quiz, it's a 0. All right? That's just the way it's going to be. So then we have, 3 exams. Is it 3 exams on here? Yeah, 3 exams and a final. So a lot of your grade is what you do on tests. Clear? Okay. Everyone always asks, is the final comprehensive? Does it cover the whole class? And I'll just, you know what I mean? Does it go all the way back? And I'll just say that will depend on you as a class. If the class does relatively well on the first few exams, I see no need to go back and rehash everything you've already shown you can do. Our exam 3 ends, and we have quite a bit of material after exam 3, enough that I can make a majority of the final just the stuff after exam 3. But you're all going to kind of sink and swim together when it comes to the final. Does that make sense? I mean, you're going to have to depend on each other. You may do well and not need to go back, but if a lot of the class does, then that's what the final is going to be. All right, attendance policy. Because this is a summer class, each class is actually equivalent to 2 traditional semester courses. You're allowed 4 traditional absences, so here you're allowed 2. So that's what it says here, 2 absences. At that point, if you miss more than 2, then I can either withdraw you from the course, I can drop you, or I can just let you keep coming, and at the end I can fail you. I wouldn't do that to you. I would let you know. But just know that after 2 absences, your grade is pretty much in the hands of the instructor to determine how they want to do it, even if you've aced everything. All right? So attendance is a big deal. At least in this college, we have to take roll. I actually didn't bring the roster today, but it's all right. We'll do it next class. But we will take roll every day. I'll pass a sign-in sheet around. And since I have to do that, I'm going to stick to this thing. If you decide you don't want to be in this class anymore, it is your responsibility to withdraw. Okay? Do not assume that I will drop you from the course. I made that mistake my second semester of college. I just stopped going to classes. I was just having way too much fun. So I assumed, well, look, I only went like 1 time. They're going to drop me from the class, right? Well, no. They just give you Fs. And that's what will happen here also. All right, so I did not enroll you in the class. If you don't want to be here, you need to unenroll yourself. 6 drop rule. This is a Texas thing. I don't really want to get too much into that. Just know that any college level course in Texas, if you're at a public institution, you can drop a total of 6 classes. Total. In all the colleges you go to, you can drop 6 classes. after your sixth class, you start paying out-of-state tuition. That's a big deal. All right, so you don't want to get into the habit of just dropping courses all the time, because at some point you'll pay for that financially. Tutoring, so right across the hallway there's 2 tutoring labs. There's the big one over here, 316, and then there's one over here, 308. 316 is where you go sit down maybe with a couple of classmates and do your homework. There's tutors in there. You can raise your hand and you can get help. All right? I encourage you to try and make some friends, work together, probably benefit you. And then the other lab is where if you need one-on-one tutoring, they can do that and give you a couple of sessions, 30-minute sessions. The catch to that is that they can only help you if your question is developmental, meaning it's not necessarily the college algebra that's getting you, it's something that you should have known before you got here. Okay? That's what that, because that lab is designed for developmental classes, not for college level. Make sense? So you can still go there, but your question has to be of a developmental math nature. All right, the SOBI statement. I'll be honest, I really have never read through all this, and I've never really clicked on all these links. So I've just kind of formed my own opinion as to what it is. I see in here something like strategies of behavioral intervention. I think this has to do with just how crazy the world we live in is, right? Because people like every day are going and shooting people and acting crazy, right? I think this just has to do with if you see something that seems out of sort, don't just sit there and be like, that person that was on the news that was like, yeah, I saw that guy, he had this big old, gun hanging out, and I just, walked away. If you see something out of the ordinary, talk to someone about it, right? If someone's just acting weird, let everyone know, or let someone know. Now, I always like to look at the classroom we're in and try and determine if there's an active shooter, right? Someone in the hallway going down there shooting up the building. What are our options? And I've taught in this classroom, and I can tell you there's not an option out these windows. I'm pretty sure this would be a fatal fall, okay? We're on the 3rd floor, and it's concrete down there. So there's some buildings where there's actually awnings and stuff that you could jump on, then jump on, and jump off that, right? This building, or this particular room, if we ever got into a situation where there was an active shooter, we'd have to pretty much stand our ground in this room, which means we would probably pile every table we could up against that door, right? Okay. Have y'all ever heard the saying, luck is preparation meets opportunity? Y'all ever heard that? So I don't like to talk about things like this, but if you think through things a little bit ahead of time and you have some idea of what your options are, then it could be, could turn out to save your life. You never know, right? I was taught at a very young age in a restaurant to always sit facing the door. Anyone else do that? No? Did you learn that from a parent or something? Or you just do that? Yeah. I was always taught, my dad always taught me, when you sit in a restaurant with your family, you should face the door and you should always know at least 2 points of exit. And it's not paranoia. I go out to eat with my family. I don't sit there and go, like I'm just looking at everyone, not enjoying myself. But I make sure that I'm not back to the door. I know where the exits are. So preparation, a little bit of preparation. Behavioral policy, you'll like this. No texting or using phone or sleeping during class. 10-point penalty on next exam for each offense. You'll be asked to leave class. You'll be counted absent. So I have a pretty strict policy when it comes to texting, right? And just being on your phone. I know it's a long time to be in here, almost 3 hours. And I know it's hard for some of you to possibly disconnect from the grid and not update your status and, whatever, but you have to do that in this class, all right? If you need to step out of the class, go ahead. Go in the hallway and, I'm hating this class right now, and then come back in. But just don't sit there in class and be doing that, all right? Any questions on that? Sleeping, same thing. If you're really tired, you can't hang, just leave. It's better to take an absence than to take a 10-point penalty on a test. All right, schedule. I already have that there in front of you, but it's also here. It just doesn't look as nice here. So, and then everything after that is stuff that I'm required to have in here. In fact, I don't have any control over. I can't take it out if I even wanted to. So that's all college stuff from there on out. Questions over the syllabus? No. Nope. It's a college level course. There's no lab component. Yeah. The schedule? Sure. Who else? Your whole table didn't? Really? I'm already picking on you. There you go. Okay, yeah, good question. On the homework, my expectation is that you have either a spiral or something where you're doing all your homework, and you do it, you just keep it there. Like I said, I normally won't collect it because if I collect it, that means I'm going to have to grade it, and there's just no way I could get it back to you in any reasonable amount of time. So normally it'll be just visual checks, and so you can keep it in a spiral, keep it in a binder. What I would ask you do is bring all your homework every class, because I may not check your homework next class, right? But then the one after that, I may say, hey, let me see all your homework, you know, for everything that you've supposed to have done up to this point. And so if you don't have that with you, like, oh, I left it at home, then you won't get a grade. It's to check that you're doing it. Okay, the answers are in the back of the book. So if you do the work, I know it's not the same, but if you do the work and you're not getting to the answers, then that means you should be getting help. And that help should be either tutoring lab or myself. Okay, that's the idea. I know it's not a perfect world. We can't, unfortunately, I can't grade everything. I wish it was just like, okay, I have 3 students and, you know, that's it. But okay. Any other questions? Let me make sure I've covered everything that I want here. Class videos, notes. How about that schedule? Should we discuss the schedule? See when our first test is? It's not liking that. There it goes. So notice that these are kind of blocked off. Usually each day we do 2 sections out of the book. So we've got this week, we've got the following week, and then let's see, 3rd week. Where's the test? Oh wow, oh, oops, I skipped it. So we have a test next Thursday. All right? That's right, isn't it? This Thursday, the next Thursday. Yes, we have a test next Thursday. It'll cover chapter 2 basically. And we will review for it next Tuesday. Now, remember I said I'm going to do a class and we'll about halfway we'll break and then we'll continue. Well, because of that, I've actually split up the course, the days like that. So on Tuesday of next week, we'll do 2.8, and then we will have a review over everything for the second part of that class. And then we come in and we take an exam in the first part of the class, and then we will do 3.1 in the second part. So unfortunately, when the exam is over, you don't get to leave. You have to stay, and then we continue. I know that kind of sucks, but there's only so many days in the summer. And we actually have a holiday, so we lose a day. July 3rd is a holiday. All right. The last day to drop the class is this Thursday, July 17th. So we're going to cover, let's see, Chapter 2, Chapter 3, Chapter 4, Chapter 5, then we're going to jump to 6 and get a little bit of 8 in there. We ready? Okay. All right. So, day one, what are we supposed to do today? R4 factoring. Now, this is actually a section in the book, okay? R stands for review. So this is the fourth section in this book on review, and that fourth section has to do with factoring. Prior to this section is R3, which is exponent, scientific notation. Prior to that is R2, algebraic expressions, properties of real numbers. And so we're not starting off in the very beginning of this book. We're going to start a little bit into the review. Now, factoring is one of those skills that you need in this course. You need to be able to factor. So I want to see where everyone kind of is with this. I'm going to assume you know how to factor. That has to be my assumption coming in. But as I do some problems, I'm going to ask you to do some problems, and I'm going to kind of walk around and see where everyone is with it. All right? That's the way it'll work, at least to start off today. Okay, I'm ready to go. Do y'all have any last requests before we? No? No, you shouldn't. Well, you shouldn't. You might, but I mean, you're not going to be. You can use your phone now. Yes, today is fine. Okay, so let's talk a little bit about what factoring is, just as a reminder. All right, factoring would be something like this. If you took 2x and then in parentheses x plus 4, just take that right there. First of all, let's get some language established. This is multiple choice here for you. An expression or an equation? It's an expression. It's an expression because there's no equal sign, right? So this is an expression. It's a mathematical expression. Right now, one thing we could say to do is to multiply this out or expand it, which would mean distribute the 2x through the parentheses using the fact that this right in here is an implied multiplication. We don't usually write the dot or the multiplication symbol, but it's implied, it's understood. So if I multiply that out, what is 2x times 2x, that first multiplication? 2x squared, okay? And then if I do the second multiplication, I get 2x times 4 is 8x, right? And what symbol is between that? Plus, right? It was positive. All right, so that would be it. So if you were asked to go in the direction from left to right, this would be called expanding. But just like most things in math, if we can do it in one direction, then there should be a way to undo it and go backwards, right? And so the operation of actually going backwards here is what factoring is. So you should have been shown all these different techniques of factoring. And the whole idea was to take an expression, again, this is an expression, and to rewrite it as a new expression, but with the very important idea that now you have in here multiplication. Okay, you started out on the right side with two terms, right? Terms are separated by addition and subtraction. On the left side, you have a term 2x times, and then in parentheses, you have another set of terms. So you're converting addition, subtraction to some form of multiplication. So that's the idea of factoring. It's a backwards process. Now let's talk about steps for factoring. Let's see if you can recall
some of the steps that we use for factoring things. And they don't have, I don't care if they're in the right order. Let's just see if anyone can remember what anything about factoring. I know I had, 3 or 4 weeks off for summer, so I've forgotten just about everything too. So I need some help here. Anyone remember the thing you always do first if you're trying to factor something? GCF, greatest common factor. That's the first thing we always look for when we're factoring something. So our first step, our first procedure is always look for GCF. GCF stands for greatest common factor. We always try and find something that all the terms have in common, and we try and pull that out, right? That's the first thing. And I'm going to do examples, and we'll go through the steps, but let's just first lay out the steps. The second thing, after you have done a GCF, anyone recall? Well, when you pull the GCF out, you'll have something left, won't you? And whatever's left can have 2 terms, or 3 terms, or 4 terms, or 5 terms. And hopefully you learn that depending on the number of terms that remain, that kind of dictates what road you take as far as factoring is concerned. So the second step we want to do is actually count the number of terms that remain. So determine the number of terms. And then we have a couple of cases. All right, so here's the first case. A, if there are 2 terms we try to use these formulas that we had learned. They were this one. Remember this one? What's that called? Difference of squares. We can use that formula. The formula for difference of squares told us that if you ever have 2 terms and there's subtraction between them, and each of the terms is something squared, then you can reduce it down to these 2 factors. Does that ring a bell? Okay, it's called difference of squares. I'm just going to put next to it difference, D-I-F-F, difference of squares. Weren't there a few other formulas that we had that were kind of like difference of squares? Difference of cubes was another one. And that formula wasn't quite as easy to remember as difference of squares. But I will allow you to have a cheat sheet on all your tests. And so like a formula sheet. So you will be able to have these formulas written down. And then there was another one. That was difference of cubes. What was the other one? Sum of cubes. Sum of cubes. If you have 2 things being cubed and addition between them, then the formula looks very similar to the one above. It's just a couple of the signs are different. That was called sum of cubes. Is there a sum of squares formula? No, there is not. These are the only 3 common formulas that we have. And so those are the ones that you should be thinking about. So let's back up again. You always try pull GCF out. You get that done. After that, you count the number of terms. If there are 2 terms, you hope, okay? You hope that what's still there, the 2 terms, that it looks like one of these 3 things. If it does not look like one of these 3 things, you're probably done factoring at that point. You can't do any more. But that's what happens if we have 2 terms. What if we had 3 terms? What if you had 3 terms? Anyone remember what you do if you have 3 terms. We use something called, depending on how you learned it, something like the AC method. AC method. We're going to review all this. I'm going to give you examples, but that's hopefully, again, ringing a bell somewhere in there. We use the AC method to try and factor. And what if it's 4 terms? We use, how do you factor something if it has 4 terms? How do you try to factor something if it has 4 terms? Grouping. We use grouping. And then I'll put the next one in blue. What if you have 5 or more terms? Well, prior to this class, you would never have 5 or more terms. They just wouldn't do that to you. It's too cruel, right? But now you're in college algebra. If we have 5 or more terms, I'm just going to put here, stay tuned, folks. Stay tuned. That's what's coming, okay? We will be able to handle things with 5 or more terms, just not yet. All right, part of what we're going to develop in this class when we get to Chapter 3, after the first exam, all right, is when we'll start to attack this situation. Okay, so that's the standard set of steps, techniques that are utilized to factor, all right? It's basically GCF and count your number of terms. Once you know the number of terms, you try these things. All right, so let's do a couple of examples. I would like for you to factor I'll give you 3 of them to do. Negative 13n squared minus 52. Or we'll do 3 of them. Let me start with that one. So let's factor this. All right, what's the first thing that we look for? GCF, right? A common factor. So what I like to do is I like to look at the numbers first. I have a negative 13, I have a negative 52. Is there a number that goes into both of those? Yeah, 13 is a factor, right? They're both negative, so we could say negative 13. So you start thinking about numbers like 2 doesn't go into each one of them, then you try some other things, and you realize, well, wait a minute, 13 itself goes into 52, right? How many times? 4 times. So we can actually factor a negative 13 out of this. So we take the negative 13, we write it on the outside. Then inside the parentheses, what would we have left? N squared plus 1. Plus 4, sorry. So this equals this. Agreed? And now what we do after we pull GCF is we look at this in here and we say how many terms? There are 2, right? There are 2. Now if we go back to the previous page, if there were 2 terms, we hoped that it would fall into one of these. Now what's the operation that we have between ours here? Sum. And the only formula we have for sum with 2 terms is sum of cubes. So the question is, are these cubes or not? No, they're not cubes, not perfect cubes. So at this point, we cannot break this down any further. We cannot factor the inside. Therefore, we are done, and this problem is over. And we box it up, and we move on. Okay, let's try another one. B. 9p squared plus 27p cubed minus 18p to the 4th. Don't worry, I'm not going to just do the whole class of me doing this, all right? There will be time some point where you're going to be able to work and kind of wake up again. So first thing here, factor, common factor. 9 goes into 9, 9 goes into 27, 9 goes into negative 18. So I have a common factor of 9. How about variables? I have p squared in the first one, p cubed in the second, p to the fourth in the last term. So I can pull out what they all have in common. They all have at least a p squared, right? 2 factors of p. So I can pull out p squared. And that's it, right? There's nothing else? So then in here we have what? Be careful on that first one there. It would have to be a 1. Yes. I'll put it in red to make sure everyone understands. We have to be able to multiply here to get this, right? We need that there. So we can't just not have anything. We have to have the 1 there so it distributes, hits a 1, then becomes the 9p. Now what? Nope, no p. Yeah, just a 1 because we already have the p squared. Okay, what about this one? We need to turn the 9 into a 27 positive plus 3. And then we need to turn the p squared into p cubed. So we need a p. All right, how do we turn 9 into negative 18? Multiply by negative 2. How do we turn p squared into p to the 4th power? We need p squared again. What do you actually do when you multiply p squared times p squared? Are you multiplying those two or are you adding them? You're adding them, right? Okay. So that's it, right? At this point. Now, we still have to address what's inside here, right? We have to look at what's inside here. How many terms do we have there? There are 3, right? We have 1, 2, 3. So we may have to do now an AC method on this. So let's try an AC method. So what I'm going to do, I'm going to go to a different color. I'm still doing the same problem. I'm going to write out the part that I'm trying to continue to factor, which is this. And the AC method is as follows. You want to take your 3 terms, you want to put them in descending order, highest power of your variable down. So I'm going to change the order, negative 2p squared plus 3p, and then plus 1. And now the method. And this is all going to depend on you, how you learned it. You may have a way already that you are completely comfortable with, completely happy with. All right? And if you do, I'm not here to try and undo that. All right? But I have to show you at least something to do, right, in case you're stuck. You look at the number in front of p squared and the number on the back end, the constant 1. You multiply those two together. And people do this different ways. Some people do little tables or charts or whatever. The way that I've always done it is I put the negative 2 times 1. I put it right here, negative 2. And then you look at the number in the middle, which is a positive 3. I put that right here. And does anyone remember what we have to do now to get this to work? We have to think about something, right? We have to actually come up with 2 numbers. We have to mentally think about numbers and go, are there 2 numbers that I can think of that would multiply to give me negative 2, but add up to give me 3? Can you think of 2 numbers that do that? That multiply to be negative 2 and add up to be 3? How many different ways can we get negative 2? We could do 1 times negative 2, right? And we could do negative 1 times 2, right? Isn't that the only way we could get a negative 2, by multiplying 2 numbers? Right? Both of these give us negative 2. But is there any way that we could take those 2 numbers and add them and get 3? What's 1 plus negative 2? Negative 1. What's negative 1 plus 2? Positive 1. So there's no way we could put those together and get 3. So once we create this little chart over here, We try and come up with these two numbers, and if they existed, I would have put them right here, okay? Would have put them on each side. If we can come up with those numbers, then we continue the process. If we cannot come up with the numbers, then at that point we are done. We cannot factor that. So our answer is actually up here. Does that make sense? We couldn't break that down any further? Okay, let's try something slightly different. I'll start a new page here. I'm doing a different example because the technique here is slightly different than what we just did. 9x, oh wait, I'm doing the wrong one, pardon me. 6h cubed minus 9h squared minus 2h plus 3. How many terms? Oh, sorry, GCF. GCF. Is there a GCF? Yeah, 2 goes into 6, but not 9. So I can't pull a 2. 3, no. 3 goes here, 3 goes here, 3 goes here, but 3 doesn't go into -2. So I don't see a number that's common to all of them other than 1. How about variables? No? H cubed here, H squared here, H here, and here? No. So I cannot pull an H out because they don't all have an H. So I can't do anything as far as GCF is concerned, right? So now I count the terms. How many terms? 4. And what do we do when we have 4? We try to group. We use grouping method. Now again, this will all depend on how you learned it and how comfortable you are with it. Here's the way I do it, and this is the way I teach it. If you have 4 terms and you want to attempt grouping, right after the second term, you split your expression. And then you focus all your attention right now on just the first 2 terms. And from those first 2 terms, just those 2, pull a GCF. So what GCF can we pull out? We can pull out a 3 and an h squared, right? And what would be left here if I did that? 2h minus 3. 2h minus 3. Now, in order for grouping to work, hopefully you remember this, in order for grouping to work, you need to have the exact same thing over here in another parentheses. So now what we do is we focus our attention on the other 2 terms, and we pull a GCF out of these 2. Is there a GCF? Doesn't look like it, right? But what do we need to have in this parenthesis right here? What has to be there in order for grouping to work? It has to be this, doesn't it? 2h minus 3. Well, I have a negative 2h plus 3, right? I need it to be a positive 2h minus 3. So what can I do to turn that into a positive 2h minus 3? I can factor a negative 1 out. So I'm going to factor a negative 1 out of these, and that would leave me with the 2h minus 3 as I needed. I'll put an equal sign in front of all this. So that, those 4 terms turned into this. Everyone see how that worked? Okay. Now that these 2 things match, since that's our common factor, we can rewrite this as 2h minus 3. That's whatever they both had in common. And then in a separate parentheses, what do I put here? 3h squared minus 1, which really was just the numbers that were out in front, or the factors that were in front of each of those parentheses. So that went here and here. Okay. Look at that now. We have to pay attention to this. Can we go any further with this? How many terms? 2. 2 terms, well, could be difference of squares, sum of cubes, difference of cubes. Does that look like a difference of squares? No. Difference of cubes? No. So look at this one now. How many terms? 2. Difference, right? Do we have difference of squares? Well, the h is squared, right? Is 1 a square? 1 is 1 squared, isn't it? Right? But 3 is not a perfect square. So since 3 is not a perfect square, I cannot split that up. Do you all follow that or not? If I had this instead, could I have gone further with that? Yes, because 9 is perfect square, h is perfect square, and 1 is a perfect square. And then that would have been able to go further. But because of that 3 right there, not being a perfect square, it won't go any further. So we're pretty much done there. All right. New example. How about this one? Negative m squared plus 13m minus 42. GCF. Is there a number that goes into all those? No. Is there a variable in every term that's common? Not in every term, so we technically don't have a GCF. Now, could you factor a -1 out? Yes. So just be aware. Remember, you can always factor -1 out of anything, and it has the effect of changing the signs of all your terms. So I'm just going to remind you that that is possible. Now, it would not be incorrect if you just left it this way, but just remember that that is something that we could do. Now, I'm not going to do it, okay? I'm going to just stick with this over here. Now, how many terms do we have? 3 terms, right? 1, 2, 3. So if we have 3 terms, we are going to try this AC method. So how did we do AC method? We took the number that was in front of the variable, which for us would be -1. We took the number in the back, which for us would be -42. We multiply the 2 together, and we put them in this little thing over here. -1 times -42 is +42. And then, what goes below that? Well, the +13. And now you have to come up with 2 numbers that multiply to be 42 and add to be 13. Does everyone understand that if you have your own method that you learned and you can factor that without any of this junk I'm doing on the side, that's okay? Yes? And stick with it. But if you are lost at this and you don't know how to factor that, this at least is a guide for you. Can you think of 2 numbers that multiply to be 42 and add to be 13? 6 and 7. So what I do is I put that here, 6, and I put this 7. Could I have done 7 and 6 written the other way? Yes, right? Okay, now the critical step. How do we use that to come up with our factoring? What we do is we rewrite the problem, -m squared, and then I'm going to write the -42 out here. So basically the 2 ends are going to stay the same, except that middle piece, the +13m, is going to be written using the 6 and the 7. So I'm going to say, instead of 13m, that's the same as a +6m plus 7m. That's just a tricky way of doing it. Do you agree that 13m is the same as 6m and 7m put together? Yes. The reason we do this is because now, how many terms do we have? 4. And since we have 4 terms, we do grouping. Again, if you can do this factoring mentally without all this, go for it, all right? Now, with grouping, we said factor out a common factor out of this first one. So what can I, or first 2 here? What can I factor out here? M? What would you be left with? Negative m plus 6. Okay, we need the exact same thing over here, don't we? So what I like to do in my classes is I tell my students, look, just put whatever it is that you need to match, right? Don't we need that to happen for this to work? And then I tell them, okay, just come up with the number out here that makes it work. So what would I have to multiply here to give me this? 7 won't work. I need negative 7, right? Because I need, if I do 7 times negative m, that gives me negative 7m. I need the negative to go away, so I need negative 7 out here. So I'm going to stick a negative 7 out here. Let's just check it. Negative 7 times negative m is positive 7m. Negative 7 times positive 6 is negative 42. It works, doesn't it? And now that these match, I just rewrite whatever matched. And then in a new set of parentheses, the 2 things that were out front, m minus 7. I do a quick check. I can't go any further with this. It's not a sum of squares or sum of cubes or anything here. No difference of squares, difference of cubes. I'm done. Box it up. See, it's 304. I think I'll do one more example. No, I don't think I will. I think I'm going to let you do some now. Okay, what I'd like for you to do, we'll call this classwork. For all of these problems, factor. All right, there we go. So there's 4 problems for you to go through. What I'd like for you to do is when you get to a result, just raise your hand. I'll come by and take a look. Help each other out. Make a friend. We're all in this together for 8 weeks, so no need to be shy. All right? And raise your hand if you have questions. I'm going to pause my video. See the technique. So let me take this first one here. Whoa. Well, that didn't work. it this way. All right, for that first one, GCF. So when I look at that, I see a 3. I could pull a -3 out or a +3. I see an a squared common factor. So I'm going to choose to pull a -3a squared out. Could you have just pulled 3a squared? Yes. I chose not to. What remains is this. All right, so any questions on that step? Now, what's in the parentheses has how many terms? 3. 3 terms means AC method. What you have to do first, though, is put it in descending order. So I have to rearrange this highest power of the variable down. So focusing all my attention now on just a squared plus 2a minus 3, I try and come up with these two numbers that will be, let's see, -3, and multiply to be -3, and then add up to be the number in the middle, +2. And the two numbers that do that are 3 and -1. That's weird. Right? 3 and -1 are the numbers that do that. So then what I do is I rewrite the problem. Okay. So what stays the same here? What do I rewrite this, right? But what do I not change? The outsides, right? So the a squared stays the same, the -3 stays the same. The inside, the 2a, rewrite it as what? Plus 3a, that's using that 3 over there, and then minus 1a. So I just used the 3 and the -1 from there. Now I do grouping, pull out an a out of the first one. Over here, pull out a -1. Since these two match, you get a plus 3 times a minus 1. And that was just that part on the side. We still have to come back here and put it together. So I pulled -3a squared out, and this whole thing just turned into a plus 3 times a minus 1. All right, on the second problem, is that all right? Can I keep going? Yes. No, you could put a minus 1 in front of a plus 3. All right, on the next one, how many terms? Well, GCF, do I have GCF here? No? No GCF? How many terms? 4 terms, so it's just grouping. What can I factor out of the first two? H to the 4th. What's left? H minus 12. I need the same thing on the other one, so I pull out a -3 or factor out a -3. I'm left with H minus 12 over there. Since those two are the same, I put H minus 12 out front, and then what goes in there? H to the 4th minus 3. Now, I have to be a little careful here. I have to keep looking at these. 2 terms, 2 terms. No squares or cubes here. How about here? H to the 4th could be a difference of squares, but because 3 is not a perfect square, I don't have to worry about it. So I'm done. Next one. Three terms, right? No GCF, right? 3 terms. What number goes up on top there? Because I'm doing AC. The 1 times -45, is negative 45. And then the number in the middle is negative 4. What two numbers multiply to give you negative 45 and add up to be negative 4? Negative 9 and positive 5? Did I write that problem down right? Is that correct? Yes? Okay. All right, next. Well, that's a way to do it, but that's not the way I've been showing it, so I don't want to do that. You rewrite this, right? Do not touch the ends, right? The middle, negative 4x, is rewritten negative 9x plus 5x, using the two numbers we just got. Then I come in with grouping. Factoring a GCF of x out of the first two. Factoring what out of the second two? Positive 5. You're left with x minus 9. So you're left here, you have x minus 9 common to both, and then in parentheses, the two remaining pieces. The two remaining factors that were out front. Okay, last one. It's a lot easier whenever I do it, right? Just watching. It's the way math works. I mean, you really don't get comfortable with it until you start doing it yourself, right? And that takes time and practice. All right, 3 terms. Do we have a GCF? Oh, okay, so let me try this little method over here. Multiply 4 times negative 15. That gives me negative 60. The number here is 7. I have to try and come up with some numbers, and that's going to maybe take a little while to come up with those. But eventually you get what? Negative 5 and positive 12. If you need a calculator to do that, use a calculator to try different things. But eventually you should get negative 5 and 12. They multiply to be negative 60. When you add them together, you get 7. So now I rewrite this. I don't touch the ends. The middle term, 7q, is going to be rewritten as minus 5q plus 12q. And then I do grouping. What can come out of the first two? Q? That's it, right? What can come out of the second two? 3, right? 3 is a common factor in these two, which leaves you with 4q minus 5, which is kind of what you needed, right, for these two to match. At this point, we're pretty much done. Now, we're going to continue on with some more stuff here with factoring, but I wanted to take just a moment to ask you your opinion on why it is that you have to take a math class like this for your degree. Let's see, a lot of people said they're not doing math, so let's see. Someone tell me if you feel like it, what your major is. Anyone know what their major is yet? Okay, education, animation, communication, nursing, film, psychology. So why the hell do we need to know how to factor, right? Not only that, but you've got the T89 over there, right? That calculator, and it has a factoring built-in function. You can just type in, and you just hit factoring, you type in whatever's up here, you close off the parentheses, you hit enter, and it does it all for you. All right? There's even a website called Wolfram Alpha. Has anyone ever seen this before? Okay, let's see. Let me take the one that we just take, what did we had? We had x squared. What was the one we had? It was x squared minus 4x. Was it minus 4x? Minus 45. If I just go to this website that's free for everyone in the world, and I type that in and I hit equals, it's going to do a lot of things. But one of the things it's going to do is it's going to factor it for me. See? And it does a bunch of other stuff, and I mean, just crazy math stuff on it, right? So my question is, if it took me about 30 seconds to go to a website and do exactly what you just did by hand, why is it that you're required to do this? Any guesses? I'm not saying I have the answer, okay? I'm asking you what your opinion is, because I think the way that you approach math is kind of indicative of how you will do in math. You know, if you really just hate it because you don't even know why you're doing it, then it might be more of a struggle. But if you can find a purpose for it, a reason, then maybe it'll be, you know, a little bit easier to manage. So, film, nursing, why do you need to do this? No one has an opinion? You're just doing it. They told you to do it. You're just doing it, right? This is what you need to take. Do it. Don't ask questions. Makes you well-rounded. So you hang out with your friends and talk about factoring? No. Yeah, man. Doing this factoring 3 terms the other day. Man, it was fun. Yeah. Well-rounded, I agree. Okay. Art. Did someone say art? Film? Film, okay. How about English? Any English majors? Who likes writing papers? Reading? Yeah? Okay. So everyone has their own kind of niche. General education, a college degree, bachelor's degree, is supposed to be a general education. You have a little bit of everything. You may not like some of it, but it's a little bit of everything. And a course like this is designed not to teach you how to factor so that you can go into the real world and factor. It's to teach you how to learn different things. You may not enjoy this. Your brain may not work very well when it comes to math, but taking courses like this is supposed to help get your brain to be able to think different ways, and not necessarily the way that you like to think. A lot of what I want you to succeed with in this class is steps and processes. By the end of this class, you will succeed if you can follow steps and processes. This is the stuff, the little parts of it inside that you'll have to be able to do. But generally speaking, can I give you a set of 8 steps, give you a problem, and tell you do this? And can you follow that set of instructions? That's what it comes down to. So for me, it's more about, think of an employer who wants to hire you. You have someone with a degree, you have someone without a degree. The degree is supposed to represent the fact that you have demonstrated the ability to learn various things. That's the way I think about it. I know none of you will be factoring, right? All right. With that in mind, let's continue factoring. So let's try something that we haven't done yet. How about 4x squared minus 1? So we need to be a little quicker, okay? This is review topic. Let's try and move a little faster here. GCF, yes or no? How many terms? Okay, so therefore, what does that look like? It looks like difference of squares, right? 2 terms, one of them, 4 is a perfect square. X squared is obviously a perfect square. 1 is a perfect square. So to do difference of squares, what you need to be able to do is rewrite your problem as 2 things being squared. That's the first thing you have to do. So I can rewrite 4x squared as 2x squared in parentheses. So if I take 2x and I square it, I would get 4x squared. And then over here, what would I need to square in order to get 1? 1. And then following the formula, this is like an a squared minus a b squared. And the formula says this will turn into what? A plus b times a minus b. So for us, what would A plus B times A minus B, what would that turn in? What is it? Okay, be careful. The A here is what's in this parentheses, not with the squared, okay? So it'll just be just the 2x. No, that's all right. 2x plus then whatever is in here, 1. So it's exactly what I'm highlighting. That's your A and that's your B. The A is this, the B is this. So it's A plus B and then 2x minus 1, A minus B. Box it up. You're done. Eight minus 27w cubed. GCF? No. 2 terms? Difference of, well, there's a cube that's kind of giving it away a little bit, right? The only thing you have to resolve now is 8 a perfect cube and is 27 a perfect cube? They both are, right? So I need to be able to rewrite this as something cubed minus something cubed. So how can I get 8? By cubing what? 2. How can I get 27? 3, and then how do I get w cubed? I have to cube a w, don't I? So if I cube 2, I get 8. If I cube 3w, I get 27w cubed. So for me, my A here is 2 and my B here is 3w. And then go to the formula I gave you earlier. This should turn out to be A minus B, then A squared plus AB plus B squared. Okay, what'll it be in here? What's A minus B? It'll be 2 minus 3w. What's A squared? 4 plus what's A times B? 6w, right? Because that's 2 times 3w. And then what's B squared? Be careful on that one. 9w squared. Good. These videos together into one, so it's not 4 different videos. Okay. Any questions on that? Difference of cubes? What if this had been a plus? The only thing that would have changed is this would have been a plus, and that would have been a minus. And the rest of everything stayed the same. All right, I think that, yeah, that this all may be a sign that we're ready to move to another section and get out of this factoring for now. I will write down your homework assignment out of here. There's not a homework assignment out of the factoring review, but after walking around, I think we should probably try these. Page, I think there's a chapter review here. It's page 42. How about 7, 9, 11, 13, 15, 17, and that'll be it. Now each one of those problems has like part A, part B, part C. Some of those you've already done. So I gave you a couple of those problems, like the ones that you were doing before we took a break, are some of those. So just take a look at that when you compare it in the book. All right, we're also supposed to talk about, we're supposed to get into chapter 2 today and talk about linear functions, linear graphs, linear equations. I think you'll probably like this more than factoring. So let's start here with 2.2, graphs of linear equations. Again, this should also be concept review because like we cover linear equations in 302, which is one of our developmentals, and in 303. So by this time you should know how to graph a line. But let's just remind you how it's done. So first of all, a linear equation looks like this. Example of a linear equation, or the general form is something like AX plus BY equals C, where A, B, and C are numbers. So a specific example of a linear equation would be something like 2x minus 4y equals 8. So take a look at that. You have a number in front of x, you have a number in front of y, you have equals some number, right? So it's an equation because it has an equal sign. It's linear because why? Yes, we can graph, when we graph it, it'll be a line, but what is it about this that tells us it's a line? It has to do with the two variables here. The x and the y are both, if you look at their exponents, that means the powers on them, there's really a 1 on them, right? You don't write the 1, but there is a 1. If you change that, if I had rewritten the problem and I wrote that instead, it is no longer a linear equation. It is now a quadratic equation, and we'll deal with that later. So the fact that it's linear comes from the fact that the x and the y are both raised to the first power in the equation. So we know right away by looking at this, if we graph it, it should be a line. Now, what do we mean if we graph it, it'll be a line? Well, x and y, what we like to do is we like to write out our axes like this, right? Two-dimensional axes, x and y. And we like to start to talk about what x could I plug in here and what y could I plug in here to make this true. So somebody give me an x, somebody give me a y that would make this true. And I'll start with a little table over here, x and y. Someone give me an x and a y that would make this equation true. Six and one work, everyone? Yes? 6 and 1? Because if you plug 6 in for x, you get 12. And you plug in 1 for y, you get -4. So 12 minus 4 is 8. What else? 8 and 2? You all agree with that? 2 times 8? 16 minus 4 times 2, so -8. 16 minus 8 is 8. Any others? Ten and 3, right? Is that what you said? 10 and 3. Will 10 and 3 work? Okay. There's almost a little pattern here. How about 4 and 0? 4 and 0 will work? So I could turn this into 8, right? By multiplying by 4 and just make that one go away. Can you make this one an 8 and make that one go away? How can you make that one an 8? Put a -2 here, right? And then make that one a 0. So I could go 0, -2 like that. And now I could keep making this list forever, couldn't I? I mean, I could just keep coming up with numbers for the rest of my life. I would die before I finished the list, correct? So what we do is we say, instead of writing out the list of all the answers, let's try and and visualize those answers. And that's where the graph comes from. And so we talk about these points, or these answers, these solutions as pairs, what we call ordered pairs, and then we plot them, right? These are all points that we're going to plot. And as we plot these, remember the X is your left and right, the Y is up and down. So if I look at this first one, 6, 1, that means I go to the right 6, 1, 2, 3, 4, 5, 6. I go up 1, and then at that position, I put a dot. Right? And I do this for all of them. I like 4, 0, 1, 2, 3, 4, 0 was here. 0, negative 2 was down here. And what we determine is that they all lie on a straight line. So that's where the linear idea comes from. We connect them together, and we get a graph. So the line is a line, right? Geometrically, it's a line. But in terms of this equation, the line is a visual representation of all of the solutions, right? Every solution. So is it possible, would it be possible for me to look over here at like -6, let's say 8? Just look at that point right there. Could that even be a solution? So like right away, if I said, hey, plug in -6 and 8, will it work? Well, without the picture, you might have to think about it a little bit, right? But with the picture, it's automatic. You know that there's no way that that would work, right? Okay. All right, now graphing lines this way with a table is way too tedious. So what we learn is that there's two shortcuts to graphing lines. There's called the intercept method, and there's called the slope-intercept method. Either way. And I want to make sure you understand both. So the first ways to graph lines, the two ways are one, intercept method, the next way is use the slope-intercept method. Those are your choices for graphing lines. So let's talk about the intercept method first. The intercept method. The intercept method comes from the idea that if you have a graph, okay, if you have a graph and you have a line, right, that most of the time, not all the time, your graph should hit both your x-axis and your y-axis, right? And those points where it hits are called the intercepts. So if we can just find those 2 points, we could always just draw a straight line through them, couldn't we? And that's the method, the intercept method. You find the 2 points where they hit. What can you tell me about this point right here? What's always true about that point? The y-coordinate is 0. This is always 0. Now what's the x-coordinate? I don't know. But that's what we'll do. We'll actually replace the y with 0 and then go figure out what x is. And this point, what's always true is that x is 0, and then the y-coordinate we can go find. So the method is actually this. You find the x-intercept first. All right? That's what we'll do for intercept method. Find the x-intercept. How do we find that? Set y to 0 and solve for x. Then we will find the y-intercept. How do we do that? The opposite, right? Set x to 0 and solve for y. right? All you need to draw a line is 2 points, right? So if we find these two intercepts, we should be in business. When would this not work? When could we potentially run into an issue here? If that line is, what if it's a horizontal line? This horizontal line has a y-intercept, right? But it doesn't have an x-intercept. Or if we had a vertical line like this, then it has an x-intercept but doesn't have a y-intercept. So those are like the two exceptions, vertical and horizontal lines. But we have an easy way of graphing those because they look very unique when you write them out as an equation. All right, so let's do the example we just had. It was 2x minus 4y, okay, equals 8. I couldn't remember if it was. All right, that's what it was, right? Let's graph this using the intercept method. So let's find my x-intercept. To do that, I'm going to rewrite the problem, the equation. I'm going to replace my y with 0 and then solve that for x. So that term vanishes, right? Negative 4 times 0 is 0. That's gone. So all I'm left with is 2x equals 8. And dividing both sides by 2, we get x is 4. Now remember, this is a point, right? We said the y was 0, right? That's how we started the problem. We said y is 0. And now what it says is if y is 0, x has to be 4. So that's my x-intercept. And then to find the y-intercept, I do the same thing, except this time I replace x with 0. This time the x term cancels, or the term that had the x in it goes away. I'm left with negative 4y equals 8, which means y is negative 2. And so we had replaced x with 0, and that means that my y is negative 2. Once we have the 2 points, I plot them and I'm done, right? Draw a line, I'm done. So that's the intercept method. The other method is using the slope-intercept form of a line. So let me show you that. The slope-intercept, I'm just going to say slope-int method. Okay, the slope-intercept method works as follows. We still have a graph. Okay, we still have a line. I'm going to draw my line a different way this time. We still have x and y intercept here, right? We do have intercepts, but all we do for this method is we start with the y-intercept, and from the y-intercept, we somehow determine how much we have to go up and how much we have to go over to get to another point on that line. How much we have to go up, we called the rise. How much we went over was called the run. Remember this? Rise over run. And it turns out that if you're given any linear equation, okay, if you start with any linear equation, if you solve for y, it'll turn into something that looks like this. This is called the slope-intercept form of a line. And there's some very telling pieces of information when you solve an equation like this for y. What is the m in the front? The m is your slope. So it is your rise over run. And then what is the b in the back here? That number will always be your y-intercept. I'm going to say y-int. So what we do for this method is we make sure we solve the equation for y, and then we use the numbers that are generated when we do that to somehow graph by just moving up and over. So let's do the problem we just did again using this method. Let's do 2x minus 4y equals 8 using the slope-intercept method. So what do we have to do for slope-intercept method first? Get y by itself. We got to solve for y. So let me try and solve for y here. I want to isolate this y by itself on one side of the equation. So to do that, I first am going to take that 2x term and move it to the other side by subtracting it on both sides, right? Subtract 2x on both sides. When I do that, it goes away on the left. It appears on the right as a negative 2x, and I still have the positive 8 over there. So I'm not actually showing that, right? But that's essentially I'm subtracting 2x, subtracting 2x. Then how do I get that y by itself? I divide by negative 4. Now I will show this step. I divide this by negative 4. I divide this by negative 4. I divide this by negative 4. All terms. What is negative 4 over negative 4 over here? It's 1, right? So that's just y. And then over here, what's negative divided by negative? Positive? Okay, what's 2 over 4? 1/2, same thing. And then x is still there. Notice I separated the numbers. The negative 2 over negative 4, I reduced it as 1/2, and I just kind of separate it from the x, like a fraction out front. What's 8 divided by negative 4? Negative 2. Okay. That should be it. That's what we're going to work with. What's the slope of this line? It's rise over run, right? Which for us here is 1 over 2. So we rise up 1, we run to the right 2. And then the most important part now is this negative 2 is my y-intercept. So to graph this, very important, where do you start? At the y-intercept. You always have to start at the negative 2. You put a dot there. From that dot, from that negative 2, which came off here, make sure you don't put that negative 2 on your x-axis. So many students do that. It's a y-intercept. It goes on the y-axis. From here, to get to another point, I need to what? Rise 1 and then move over to the right 2. So I rise up 1, move over 2, put a dot. And then I could be done right here, right? Draw a line. Or if I wanted to, I could rise up again, 1, and then go over 2. I get more points, draw the line. And if you look back at the way we did that with the table, it's the same line. So what do you think? Do you think the slope-intercept method, or do you think the intercept method was quicker in this problem, was better? You think this one was better? Yeah, this way is more useful because you're getting practice with the algebra, moving things around and dividing. This way, though, in this problem, was quicker. You just plug in 0, boom, 4 fell out. You plug in 0 here, negative 2 fell out, plot, line, done. Now, for you, which way you go is up to you. It doesn't matter. To me, it doesn't matter. On a test, I just say graph the line. I don't care how you get it. I don't accept the t-table, though. It's got to be one of those two methods. All right. Let's see. What else do we need here? Let's talk a little bit again about the horizontal and vertical lines, because those were the two that we had to be a little wary of. Horizontal and vertical. Okay, if we have, let's start with horizontal. Horizontal would mean like horizon, right? Horizon. So it would go something like that. It's an example of a horizontal line. And the horizontal line always has what type of intercept? A y-intercept, right? And it hits at some place. I'm going to call that y equals, well, I guess I'll go with what the book uses, k. Right? It'll hit at some number. Y is 2, y is 5, y is 1,000,000. Could be a fraction. So if we want to try and write the equation of this line, the equation will be y equals k. That's the equation of a horizontal line. What about vertical? Vertical has what type of intercept? X-intercept. So what do you think I'm going to do instead of writing y equals k? X equals something. Well, the book uses x equals c. Okay, so it hits at c. So if you have an equation that has y in it and then some number and there's no x in there, then it's a horizontal line. If you have an equation that has x in it and a number and no y in the equation, then it is a vertical line. If they have both the x and the y and a number, then it's neither one of these, which means it has to have some sort of slope to it, which means it should have an x and a y-intercept. Make sense? Okay. A little bit more about lines. Parallel versus, they're not being compared. Parallel and perpendicular. Lines. Okay, what about parallel lines? What does it mean for two lines to be parallel? They don't touch? So I have two lines. Here we go. Here's line 1. Here's another one. Are those parallel? Those parallel? Yeah, I'm going to do my best. Do y'all agree that good enough? Okay. So the idea here is, yes, they don't seem to touch each other, ever. But what you could really say is that if you pick a point, it doesn't matter which one, to get to another point, you go rise, you go run, right? And it should be that on the other line, the same rise, same run should get you to another point on that line also. So these two lines have the same slope, right? So two lines are parallel if they have same slope. Now I need to be able to kind of write it a little bit more in mathematical terms. If we call this L1 and call this L2, L1 meaning line 1, L2 meaning line 2, then to say that they're parallel lines, we're saying that their slopes are equal, right? Slope, what was the letter we used for slope? M. So another way of saying what I just said here is that M1 must equal M2. Does that make sense? The slope of the first line must equal the slope of the second line. That's what it means to be parallel. Now, what about perpendicular? They intersect it like a perfect cross, right? Like a 90 degree. can't really say 90 degree unless everyone understands what 90 degrees is. So there we go. There's a line. Come in with another line. Those two intersect, right? They're not perpendicular, though. They're not perpendicular until I make them hit like at a perfect 90 degree or perfect cross there. So the way we say 90, whoa, what happened? That's weird. It looks perfect. Well, does that look good or no? Not really. It looks terrible on mine. It's okay. This is 90 degrees, so that's a box, okay? Good enough? Okay, so again, let's label these L1, L2. What does it take for two lines to be perpendicular? What's the relationship between their slopes? I mean, obviously they're not the same, right? Because same would be parallel. I need M1 to be equal to -1 over M2. Whoa, the hell is that? Or, see, this is a weird way of looking at this. This is correct, okay? This is what I need. The way you'd say this is the slope of the first line must be the negative reciprocal of the other line, the slope of the other line. Now just look at this equation real quick. I'm going to multiply M2 on both sides of this equation. And then what happens is over here it cancels. What's still on my right-hand side? -1. And then on the left-hand side, I have M1 times M2, right? Another way to say that two lines are perpendicular is to say their slopes must multiply to be what? -1. So if you have two lines and you have their slopes, to figure out if they're perpendicular, you multiply the two slopes together. If you get -1, they're perpendicular. Okay? Let's do a quick example of this, how we could use this. Are these parallel, perpendicular? I'm just going to put perp, okay? Or neither, because it is possible that they are, you can have two lines that are neither perpendicular nor parallel. They could just, they call them skew lines. They just hit each other, but they're not at a perfect cross, and they're not parallel. So let me give you two lines, and I'm going to make this a very simple example because of time. Y equals 2x plus 1, and then let's make the other one y equals -2x minus 4. The key here is that I've already given you both lines in slope-intercept form, haven't I? It's already solved for y. It won't always be like that. Like on the test, you probably have to solve for y. But if you can get it solved for y, what's the slope of the first one, this top one? What's its slope? It's 2, right? So I'm just going to write over here, M1 is 2. What's the slope of the second line? -2, right? Okay, are they parallel? Well, these would have to be identical, wouldn't they? So they're not parallel. Are they perpendicular? Well, multiply these two together. What's 2 times -2? -4. Is that -1? No. So these are neither perpendicular nor parallel. How could I change the problem? How could you make these two perpendicular? -1/2 in here? Right? 2, -1/2. If you multiply these two together, you get -1. So those would be perpendicular. Sorry, I didn't write up here. Neither. And over here, they'd be perpendicular. And of course, if you made the slopes the same, they would be parallel. Questions on that? One last concept. We're almost at the end here. Finding equation of line given 2 points. This is a very important skill to have. We all know that if someone gives us 2 points, we can draw a line, right? The question is, if someone gives you 2 points, can you come up with the equation of the line? The actual equation that gives you all the other points. So here's the method we use. And I'm just going to do this with an example. Let's find the equation of line through these 2 points. Mm, 110 and -17. Now I could draw this, right, and plot these points and everything else. But I'm not going to do any drawing. All I'm going to do is use this fact right here. I know that every line can be written like this, right? Except vertical and horizontal. Every other line that's got a little slope to it can be written like that. And I'm going to assume this is not horizontal or vertical, which if you just think about it, it's not. Just visualize mentally where those points are, and you'll realize it's not a vertical or horizontal line. All right, so let me go and first try and figure out what the slope is, right? What's the slope of this line? Well, we know that the slope, m, is equal to rise over run, right? The rise is going to be the difference of your y coordinates. Now, technically, the way we write that, you've seen probably in past classes, is we write y2 minus y1. That just meant the difference in the y coordinates. So what I need to do here is I need to let's call this one my first y coordinate and this my second y coordinate. This y2 minus y1 is the difference between these. And then the run is my left and right. That's the difference between the x coordinates. Have you all seen that formula? Does that look familiar to you? y2 minus y1 over x2 minus x1? That's what we use. The key here is we need to label our points so we know what we're working with. So y2 for me here is what? 7. I subtract from that what? 10, okay, over x2, which is -1. I subtract from that 1. In the numerator, I get 7 minus 10 is -3. In the denominator, I get -1, take away another 1. -2. Negative divided by negative, positive. So my slope is 3/2. So I know what m is, don't I? The only thing I don't know right now is b, right? My y-intercept. So now I'm going to go get that. I'm going to go get b. And here's the way I'm going to get b. Any questions? To get b, I'm going to write down what I know so far. I know that y equals 3/2 x plus the b that I'm trying to find, right? That's what I know. I also know that both of these points live on my graph, don't they? So I'm going to choose one of them. I'm just going to choose this one. I'm going to use it. Watch how I'm going to use it. That 110 is what I should get if I plug in x is 1 and y is 10. This equation should be true, right? So let's plug in 10 for y and 1 for x and see what happens to that equation. 10 for y. What's 3 over 2 times 1? 3 over 2 plus b. Now look at what's happened here. By using that point, I got rid of my x and my y, and I have just b in here. So now all I have to do is solve this for b. So subtract 3 halves on both sides. And your favorite part of math, fractions. How do I subtract these two? I can turn 10 into 10 over 1, right? I can get a common denominator and make it a 20 over 2 minus 3 over 2 is b, right? Just doubling the top and bottom. And then 20 minus 3 is 17 over 2, that's b. So now I know what b is. So I come back, my final answer, y equals the slope we found to be 3 over 2x, and the b, which we just found to be 17 over 2. That is the equation of the line through those 2 points. I'm going to look real quick at this homework assignment because I don't think I'm going to want you to do all of this. 7, 17, 37. Yeah, I have pretty big change on the assignment. On the assignment here for page 174, I'm just going to change that assignment completely, all right? 7's okay. I want you to do 13, 17, 25, 29, 33, 35, 39, and then number 57. Oh, I said 57. I wrote 55. Sorry, 57. Okay, so on what's here, scratch out page 174 and just do that instead. 186, don't even worry about. We haven't even talked about it, okay? Everyone have that copied? Now I had a sign-in sheet. Where is that sign-in sheet? I put it down somewhere. I don't know where it went. Did I pass it around? No, yeah, I know, but I put it down. Someone, did I? Is it over there? Okay, start passing that around. While that's going around, everyone has to wait a few more minutes. Technically, we have 10 more minutes. You're going to get out of here. Just hold tight. While that's going around, share something with you. We were talking about parallel lines, right? Everyone said that two parallel lines don't intersect, right? That's what we all kind of agreed with? Yes? Okay. Without boring you with too many details, it turns out that that's true with the geometry that we deal with in math through your whole life. That's always been the rule, right? But think about if I'm going to try and draw a road. Okay, so let's say I claim to be some sort of artist. You ready? I'm going to draw a road with some buildings next to it. That's my road. Are you impressed? Here are my buildings. Now you're looking from the top, right? Van Gogh here, right? But notice, I mean, my drawing is like mathematically perfect. All my parallel lines, right, they don't intersect each other. this road, right, the road lines, those dashes down the middle, they don't intersect, right? These are all parallel lines. They all act parallel, don't they? But it's a pretty crappy drawing. So what we realized as humans is that the laws that we work with in math don't always apply to what we need. So here's another drawing of the same scenario. Okay, you get the idea, right? Now, I think the one on the right looks more realistic, doesn't it? It's tricking your eye into thinking that there's depth here. Yes? I mean, it's a flat sheet, right? There's obviously not depth, but it's kind of tricking you. And what we realized as humans is that if we want to trick our eyeballs when we're using a flat piece of paper, if we want to trick our eyes, we need to break the rules that we have in math. Look at what happens to the parallel lines here. Where do they all go? Where do they all go? To a point, don't they? All the parallel lines in the real world, right, they're parallel. Think of train tracks, right? They're parallel, but what does your eye see? That they come together. That, in perspective drawing, that's called a vanishing point. The point at which all parallel lines will come together. So I guess the point of me showing that to you is that things are not always what they appear to be. Two parallel lines don't hit each other? Depends. In a math class, yes, two parallel lines don't hit each other. If you're trying to draw perspective geometry, then two parallel lines will hit each other. And that's how you can draw good three-dimensional stuff. So, all right, y'all look thrilled. Does everyone sign in? Who else? Okay, do your homework. I'll see you Thursday. And we move on. Before this class for an hour and a half.